Hello and welcome back. So in this video, we're looking at listing all possible outcomes of events occurring. This is also called a sample space. You know it as a sample space diagram, but the correct terms are just sample space. So in most cases, we don't need to show all outcomes. However, when more than one event occurs, it can be a useful strategy. And what I mean by that is it's a great way of making sure you haven't missed a possible outcome. So we'll look at this through some examples. And this one here, we're going to list all the possible outcomes of two coins being thrown. So if we have coin one and coin two, think about the outcomes for coin one. Well, that can be a head or a tail. And think about the outcomes for coin two. Well, that can be a head or a tail. Now, if we combine those outcomes, in this case here, we've got a head and a head. In this case here, we've got a head and a tail. This one here, we've got a tail and a head. And then finally, a tail and a tail. So they are all the possible outcomes of two coins being thrown. So if we're going to list those, you have got a head and a head, a head and a tail and a head and a tail and a tail. So there's a possibility of four outcomes. Next question could be, well, what's the chance of getting a tail and a tail? Well, there's one tail out of a total of four. So it's 1 out of 4. So what we're going to do here is we're going to look at coins 1, 2, and 3. So if we look at the outcome for coin 1, well, the outcome for coin 1 can be a head and a tail. Now, they're the only outcomes for coin 1. Now, if we then look at coin 2, let's start with the heads. Let's always try and exhaust the heads first. So look at coin 2. Well, if it lands on a head first of all for coin 1, it could also land on a head for coin 2. Or if it lands on a tail for coin 1, it could then still land on a head for coin 2. Now let's ignore coin 3 for the time being. Let's now look at finishing off coin 1 and 2. We know that actually coin 2 has not yet been exhausted. So we go back to coin 1, we repeat coin 1 because we've exhausted their outcomes. Their only other outcomes are tail and tail. So think about this carefully now. We are back in the situation like we were for the first head, head, tail, 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 tail. Now what we need to do is introduce coin 3. Now, remember what I said, we're trying to exhaust the heads first. So coin 3, we could have a head first of all. So we have 3 heads. On the second one, we can have a tail, head, head. The third one, we can have a head, tail, head. And the fourth one, we can have a tail, tail, head. Now, we haven't used any tails there. So what we do is we actually take this information, we repeat it down below. Let's do that. And now, because for this combination above, we used all the heads, we can't reuse those heads here. They must all be tails. So now we've shown all the possible outcomes. Okay, so our first part of the question was to list all the possible outcomes. We've done that. So you can get a head, 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 a tail, head, 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 tail, head, and so on through there. So there are a total of 8 different outcomes for those 3 coins. So the question now is, what is the chance of getting at least 2 heads? So, well, that's got at least 2 heads. So is that, so is that, so is that, and that's it. So the probability of getting at least 2 heads is 1, 2, 3, 4 out of 5, 6, 7, 8. Now we would call that half. Okay, so we've shown that sample space, and we can see that we can work out various probabilities by using this diagram here. Let's do one more. So on this final question, we're looking at some dice. So dice are thrown and the results are multiplied together. That's really quite key. So we're going to highlight that. So all possible outcomes, that means draw a sample space and calculate the probability of getting a score over 21. So we're going to draw the sample space and then we're going to work out the chance of getting over 21. So I've already put a table down here. And if we look at this for dice 1 and 2, we know the outcomes of dice 1 are 1, 2, 3, 4, 5, and 6, and the same for dice 2. So now what we do is we look at each die and we multiply the numbers together. So we're going to go across because what we're doing here, we're multiplying 1 by 1, 2, 3, 4, 5, and then 6. And the outcomes will be 1, 2, 3, 4, 5, and 6. Now we're multiplying all of these by 2 and then by 3 and by 4 and by 5 and by 6. So I'll just fill this in. So there we go. And our final question is to calculate the probability of getting a score greater than 21. So we want to get a probability of getting a score greater than 21 is equal to, so let's find out how many scores are more than 21. Well, there we go. All those there are scores more than 21. So we can say the chance of getting a score more than 21 is 1, 2, 3, 4, 5, 6 out of, well, you have 6 lots of 6, which is 36 out of 36. And you can simplify that by saying 1/6 if you'd like to do that. And that's it. Let's look at the second question. What would the chance be of getting a score greater than 10? So we know we've got 6 already. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. The chance of getting a score greater than 10 is 17 out of 36. So hopefully now you can see how to list all possible outcomes and you can see why we would do that. It makes calculating probabilities quite straightforward. And also now, hopefully you can remember the name of these. These are called sample spaces. You might hear them called sample space diagrams as well. So as always, if you've got something from this, please like and subscribe, and I'll see you in the next video, which is all about mutually exclusive events.